Okay, so Theodosia is with us from Australia, from the University of New England, on data visualization and statistical legacy for open and big data. I know she works a lot on education and big data, so Theodosia, the floor is yours.
And also, I would like to point an issue that I became aware while I was reviewing some of the papers coming from humanities. There is always a lack of a framework in the journal papers that are sent to for publication. So I would like to point out this issue as well and how we can, adopt a framework in your papers, in your work. So, okay, I will start with this. What is big data? This is my favorite definition of big data by De Mauro Grimaldi. And he defines, big data as the information asset characterized by such a high volume, velocity, and variety to require specific technology and analytical methods for its transformation into value. Now, in my first edited book that I will show you later, I took all of these, aspects of characteristics of big data, and I relate them to visualization of data in different disciplines. I'm not going, to elaborate on these issues. You can, take the book and read the first chapter of the book that it talks about how the volume of data can be expressed by different visualizations for humanities, for social sciences areas. The same about variety of data, and the same about velocity of data. So let's move to visualization first. Visualization is potentially a valuable way to make sense of big data in order to uncover features, trends, or patterns to produce actionable analysis and provide deeper insight. There is an increased focus on visualization over formal data analysis, partly due to the proliferation of easy-to-use web-based visualization tools. For example, we have Tableau, we have online, and partly due to an added emphasis on the power of well-designed visualizations and the demand for a new type of big data viz analysis. So we have, the so-called informal analysis of data by just looking at, the visualizations. However, the opaque, character of large data sets makes it difficult to describe in a systematic way how to effectively translate big data into visual or other kinds of knowledge. The use of data visualization as a tool for data exploration and or decision-making is not a new phenomenon. Data visualization has long been an important component of data analysis, whether the intent is that of data exploration or as part of a model building exercise. However, the challenges underlying the visualization of big data are still relatively new. So we have previous work in the literature that suggests a tendency to approach big data by repeating analytical behaviors typically reserved by smaller purpose-built data sets. So we have, visualizations that are not dynamic, are just static. The same visualization we used when we had small data sets. There appears, however, to be less emphasis on the exploration of big data, taking into consideration, the three characteristics that we have just seen, the three V's. So taking to be less emphasis on the exploration of big data itself to formulate questions that drive analysis. I'm going to move to this book. This is the book that I edited and authored in 2017. It includes chapters about different areas of the humanities, social sciences, but not about archaeology or about museum studies. Not this book. So what is good about this book? It refers to, data visualization from high school up to the university. It discusses many issues and ways regarding the visualization of open and big data and the tools we use for open and big data visualization for high school to university students without and people who don't have strong, statistical background, and even working professionals who seek to expand or formalize their data analytic skills through postgraduate university studies or through professional development programs. Although despite the new challenges introduced by the emergence of big data visualization techniques themselves need to not be new lessons from the past in the form of tried and tested graphs can still be effective, however, with a new way to perceive the data. So what I tried to say, we use the old graphs, but we use a new way to see to perceive our data. Okay, scalability and dynamics pose major obstacles to visualization, as well as the high dimensionality of our data, and the unstructured nature of the data itself, which are often captured on the form of graphs, tables, and text. Visualization of data is often captured by visual noise in the data, variation, and the issue of large image perception. That is by actual physical perception, which limits visualization of every data point that leads to overplotting and thus overwhelm decision of the data scientists, and also the perception and the cognitive abilities of the users. But on the other hand, we cannot oversimplify our data because they can lead to information loss. So a solid set of principles to avoid such distortion is required. So purpose of data visualization. So I'm trying to propose here a framework that it was used by some of the authors. This framework, it is based on an old framework of Bertin that it introduced in 1970s for the static data, but it seems that it worked very well. So let us have a look at this. We define our data by the type and level of our data, and it was claimed there that as many types of questions, components, variables in the data. So I give you an example how they propose this framework to be built. So I give you this example, and we have a data set that contains two variables, date and stock price. There are two types of questions that can be posed. On a given data, what is the stock price? And for a given stock price, on what dates was it attained? So we're trying to find the variables, and the level of question can be defined as elementary, intermediate, overall. So how can you apply this in your research? Here, in an elementary level question, the focus is on individual elements in the data. For example, places, time, snapshots, and objects. In the intermediate level, questions focus on general aspects of the data over time and space, typically involving some, but not all of the data. Or overall level questions also focus on general aspects of the data over time and space. However, all of the data are typically of interest. So you're trying to categorize your data. And we will see later why we categorize our data. Now, the purpose of data visualization. Data visualization embodies at least two distinct purposes: to communicate information meaningfully and to solve a problem. Also, we need graph semiotics. We adapt graph semiotics in the visualization because at the crux of graph semiotics are retinal variables. The retinal variables apply to data types of visualization, accuracy, as indicated. So we have the retinal variables applied to data types of visualization with accuracy as indicated. This can be used as your theoretical, philosophical framework at the paper. Now, it should be noted that data are rarely provided in a visualization-ready format. Data management can and often necessarily involves cleaning and merging data from disparate sources by means of database style merging and join-in operations, as well as summarizing data over merged frames or by groups of interest. Viewing the raw data to check validity is not possible. Processing data takes much forethought coupled with computer language skills. You can use programming language like Python in processing big data, specifically the built-in pandas library for data cleaning and merging. Python provides data structures that are amenable to large volumes of data and can be used for the fast removal of missing values, fast merging of database entries, and slicing the data into smaller subjects ready for visualization and question formulation. Complementing this choice is the use of R and SAS. This is what I'm going to use with this example that I provide to you. So the concept of dimensional type and level of a question as well as query type combined with graph semiotics demonstrated with the aid of R and SAS programming language and their respective visualization libraries. So I present here a case study because I would like to show to you all the visualizations that you can produce for these data sets. So I have here from Dominique's Finer Food Supermarket a database, and I'm using this database to produce the most important visualizations that you can use. So the supermarket database contains data recorded weekly from September 1989 to May 1987. I have approximately 98 million observations that are homogeneous in time with some missing records. So what I did The database is split in 60 files, which are classified as either general files that capture sales and store level, demographics, and category specific for the different grocery items stocked, broadly defined across 29 categories. Each time item category is defined across 2 files, we have the first contain product description, information, name size for all brands contained within the item category. And the second file contains information including weekly sales, data such as store, item, price, units, sold, total, and dollar sales. While these are just for you some food for thought, okay? It's a common example that we use when we teach analytics. So supermarkets in a database are thus considered to either the low, medium, or high price tiers. I use, the framework that I presented before. And we have also the cup fighter is assigned to those Dominique's finer food stores. And I try to create my first sample questions based on type, level, dimension, and query inside the database. So I have the 3 levels: elementary level, intermediate level, overall level. And I structure this table. And then I use this table to graph different data. For example, I have a dot plot of cheesy profit by store. We see the store on the x-axis, and we see on the y-axis the total profit. Have this other graph. Again, I have the cheese plot by price tier. So in your case, in your data, how can you adapt these graphs? What can you plot when you have the rainfall plot, for example? In your museum data. Yeah. Mm-hmm. Yes. Mm-hmm. Yes. Yeah, and you can categorize them in categories like high, low, and medium.
This is actually one of the challenges.
Yes.
You can actually, how you define high and medium and low.
Yeah.
For example, 100 visitors for the Louvre would be low, but 100 visitors for a local museum would be really high.
Yeah. So another graph that we can use is 100 stacked bar chart. Again, you have the 3 categories, and you have them according to the period of time. We can have a bubble plot of the profit or of your data set. We can have a bubble plot of Fran and Candice. It's a different kind of bubble plot. You can have box plots. The butterfly plot for your data. You can have this plot of weekly, visits at the museum. You can even create a calendar with your data. And let's say the weekly visits at the museum, or a tree map. As you can see, we have again the areas of high, low, or medium, and in this case, you can compare the visit of visit of people at one museum with the visit of people in another museum. You can have the stream graph. And what is nice about this stream graph, each line represents one item, so one data point. And it is dynamic. For example, if I will point at one line, it will show me the analytics for that data point. So we can see that we can have interaction with our graph. So for example, here we have the stores. I track my mouse, I place it on 121, and I receive this graph for this case. This can be the items of a museum. Now, I have other graphs that we can use to represent our data. I have here an example from a project. We have students' exemplars, lessons from teaching practice. We ask the students to write down if they feel fine, if they're happy, and we have, this is about the billionaires in Australia and Yemen. This is about the emotion in Australia and Yemen, these graphs. And you can see that the bubbles correspond to a particular group of people. This is another graph. We have male billionaires by region. Again, I use SAS to create this graph. You can see that we have different countries, and the biggest, is the bubble. The bigger is the bubble, that means that the person has more money. We can create this graph that it is plotting a frequency. Now, all these graphs that I show you are dynamic. That means that we can interact with them. So dynamic visualization is an iterative process that combines machine-oriented data representation and captures processing and analysis with human-oriented data, interaction, and decision-making. So with the dynamic visualization, we can interact and we can present it. With interaction, usually we specify the visual form in which the information content will be encoded, such as a spatial map showing the geographic distribution of an observed variable, set the perceptual context such as geographic area and the level of aggregation. We select the data items that will be mapped to the visual form, such as the subject of variables, and adjust the characteristics of visual elements to maximize perceptual clarity, such as to expand the view. Yes. Yeah. So we have the presentation. We present these graphs. I have also some other ways of representing, data. We have the CapMinder work. We use this CapMinder work to different, disciplines at high school. We can look at social trends and economic, changes during a period of time for all the countries. At the same time, we can produce graphs. different kind of graphs, time series. And this has been produced by Hans Rosling. Okay, the other kind of graphs that we have are graphs that we see geospatiality using Excel 3D maps. We have also specific maps that we can trace, the hotspot of theft. Students who study criminology, they use these maps, or police. We have the infographics graphs. We have the word cloud that we've seen before. We can represent big data as a network, like that. And I'm going to show you the last one is the way that we visualize big data as by Glide. Glide is a tool that it was provided by the Australia Bureau of Statistics. So what is happening with Glide? Okay, this is, the network, the way that it is represented. We represent, the data. So we have this information about Australia. We see here that we have a manufacturing industry interest in Australia, and I would like to go in to look in detail what is happening in one area. For example, I decide that I would like to explore what is happening in Victoria. I click on one bubble of Victoria, and I receive a more analytical graph. So from the macro level, I move to the micro level. If I will also continue and click on one of these areas that we have here, I receive the map of that area with information like postcode, like, information about the people, how many people live in that area, how many businesses there are in that area. I don't know if there are anything, equivalent to museums and historical places, but it's good. This is very good because you can explore what is happening in that area. And I have here future research directions. Do I have time for that? Okay. The future research directions. While visualization of big data is a new frontier and warrants further exploration, the principles that have guided visualization thus far still hold for big data, in particular that the chosen graphic should be appropriate for the data that is being visualized. Data should not be distorted for the sake of an aesthetic image, and good visualization supports the formulation of meaningful questions or insights about the data. However, it is not substitute the rigorous data analysis. So we have future research directions. There is still a need for evolution in the current state of the art, that is, the visualization of data. The call for interactive visualization marks an area for current and future exploration, which will likely become more widespread in use as visualization software becomes more sophisticated. Also, we need to develop appropriate language to talk about these, dynamic visualization tools. There is a need for a systematic approach to support the art of visualizing big data according to well-grounded statistical principles, and move away from the staggered way of visualize the data, representing the data, because big data is about movement, it's about velocity, it's about change. Future research directions: extension of the graph semiotics principles conveyed to the visualization of associated metadata of the variables. Visualizing data about data has the power to potentially provide an information-rich representation of an even bigger amount of big data, increasing the power of the analyst to extract deeper context and rich insights from the data. However, such visualization needs to be carefully balanced against the challenge of ensuring that the visual representation adheres to the basic principles of effective graphic display to ensure the analyst and other users of the graphics are not overwhelmed by formation. We have this problem, we feel overwhelmed by the formation of our data, and we need to expand the visualization vocabulary to harness the new potential information represented by interactive graphics. So there is an upcoming book titled Big Data in Education, Pedagogy and Research. This book is going to be published by Springer. It's going to be published in 2 months. And in that book, I have a chapter about museum studies and big data.